deny everything in my trial. It's only what's on the recording. And the recording is happening. Hello, everybody. Okay. So I'm still okay, I think. I mean, I'm okay visually. I still have it in 79. I still
Dr. Brady,
vision, which is not a bad thing.
you got Dr. Brady. You got to unmute yourself.
Okay. Somebody wants in?
No, he says you're muted.
You're muted right now. We can't hear anything.
No, he's
you're
not.
saying.
He's not muted.
Well, that's a good.
I'm gonna let you guys work it out. If you're both in the dorm, you can get the anyway. There are lots of people for the last 50 years wanting to mute me, but
Whoever said that you couldn't hear him, is like your Zoom audio like 0 or something?
I think I'm okay. I think
You're fine. I think you're fine.
Yes, you're fine.
Thank you.
Oh my God.
I just fell down. No, you're fine. Everybody's fine now. Okay, did you guys work that out? Because I don't know what the problem was, but if you can't hear me, I'm sorry. Turn your own sound up, I think. Okay. Now, next question.
Dr. Brady, if you can hear me,
I can hear
you're
you.
still muted. We can't hear anything you're saying.
You can't hear anybody. You can't hear anybody. Like if you tell him when he needs to do, he won't hear you. So maybe you can post something in the chat.
Can you guys chat to each other?
I can. Who's saying that?
There we go. I got it on my end. I'm sorry. That was my fault. There's something wrong with my computer. I got it.
No problem. And some of these days it'll be my fault. So, you know, as long as you guys I mean, I can't ask about these things, but if you happen to be carrying a weapon, just don't get so excited as to bring it out, okay? I am innocent. Now, I might tell you that if you do that, I might have to draw mine. Okay.
Dr. Brady, you're recording.
I know, but that's okay.
It's just here
He
saying
wants
more.
that one to be known.
That's okay. I'm well trained. Okay, both in quickness and accuracy, so it's not a problem. Okay, that's with my voice now to the recording, but thank you for reminding me. Okay, next question, maybe. I'm gonna get away from there because I can't see today and the thing blasts me. Did you get your tests?
Yes.
Anybody not get their test back, home or abroad? Now, could you find it? I don't know what you guys see. I know where I put it, but I don't know what you get. Okay, so and someday I'd like to have somebody show me what they do so that I can instruct people who have trouble with it. But right now, I'm hoping you got it, whether it was good or bad. Okay. Now, what I'm going to do is put up. I didn't want to put this on Blackboard and stuff. I don't know what the legalities are about numbers and all that kind of stuff. I think it's okay for me to display the class list of numbers on the screen, but in case people, they complain about anything, trying to get away with stuff sometimes. And so trying to be compliant with all federal rules and regulations. The results, because some of you, when you got your scores, were probably very depressed. Okay. So I wanted to put this out yesterday to say, you know, yeah, you did terrible, but 5 other people did worse or whatever. So the highest grade in the class was this, and you will see what happens. You can interpret these scores yourself in terms of like a weather pattern, perhaps. This is the scoring system. I hope I'm writing it large enough for you guys at home to see. So I can publicize it, you know, in Blackboard. I just don't see a reason to do that. But if you'd like me to, I can. I don't know what good it is to you. these were the scores. There is one person who didn't take the test yet. And it's okay. That one person, turns out, is actually in the military and being deployed at this moment. So we will work that out when the person gets out back into an indoor area where they can take a test. Anyway, so these are the scores, and basically, remember, we're heading towards 700, and you can see this. Now, I was rather disappointed because this is the kind of scores I expected to get with a closed book test. But some of you guys left problems blank and lost 20 or 30 points by just leaving things blank. And I don't understand with an open book test and open notes why you would leave things blank. I would think you would research a question. Okay, so that's just me. I don't know, again, in a closed book thing, if you're doing a test in class and you don't remember something, well, you can't answer it and you leave it blank. I understand that. But if you've got 24 hours to find the answer, if it were me, I'd find it. Okay, so I'm not surprised at the mistakes that were made. I was surprised at the number of blanks that people left. With, as I say, the ability to look it up. One question, remember, I gave you a question about the tangent function. I said the tangent function was 3/4. What's the sine? Now, the sine is either going to be 3/5 or minus 3/5, because if the side of the right triangle is 3 and 4, that makes the hypotenuse 5. The sine is the opposite over the hypotenuse, that's 3/5. The trouble is it might be minus 3/5, depends on the quadrant you're in. Okay? About 11 people out of 23 gave me an answer of 3 or minus 3. That's half of the class thinks that the sine of an angle can be 3 or minus 3. I believe you all know that the sine can never be bigger than 1, and it can never be smaller than minus 1. So if you answered the sine of the angle is 3, something should have gone off in your head that said there's something wrong here. And you had 24 hours to figure that out, which is look in the book under the appendix or read my notes. Anyway, I don't understand the sine of x equals 3. I just don't understand it. Okay? I'm sorry, but you're not bad people, and I might like all of you, but I don't understand that. And 5 people left it blank. I don't get that at all. That's trigonometry, folks. So it got very quiet in the class here, and it's very quiet at home, but you guys are always quiet at home, because a lot of times you just turn it on and go away, I know. Anyway, I'm joking now. So there are certain things on the test I just don't understand. Now, it took a long time to grade because I think you'll find on your test written out things of what you did wrong or how I could help you or what you should have said and so on each test. All right. And nobody with 110 possible points, nobody did that well. Although I'd rather be at 94 than 26. Okay. Now, I am open, you guys. I think you're finding out that I'll spend all the time of the day to you. You ask me a simple question and I spend 3 hours answering you. Okay. If you haven't tried that yet, the people who come once probably don't come again. But if you have questions, you should be asking. The people who got these scores lower, there's something wrong. I don't think you studied enough. I think you thought, oh, I had this last year, I'll just go and take it, no problem. And so it wasn't that great. Now, we will later, not today, later talk about whether you would like a retake. And if you take a retake and do better, then we don't worry about this score. Okay? We can talk about that. I presume that might be a popular idea.
Might be right.
But the game here is to learn. The scores tell me something is wrong with the learning. Maybe it's me, maybe it's COVID, who knows what it may be, but we got to fix it. Okay? We don't have to fix it, I can give you Fs. F means fine. You told me a while ago, I'm fine. You got an F today, that's fine. Okay. You can interpret it that way if you want. I got a bunch of Fs, I must be really fine. Okay? Too bad we don't have an E grade for excellent. Anyway, when I was in high school, by the way, I was in an algebra X class. And I asked, what's that? They said, oh, that's good. That's good. The other class down the hall was an algebra R class. I said, what's the R for? They said, oh, that's for retarded. Can you imagine naming a class retarded? Officially on the schedule? I'm going to go take retarded today, you know? The expectations in that class, you know, I got a C in retarded algebra. Anyway, let's not worry about grades, let's worry about knowledge, okay? Every problem that you missed, you ought to go back and learn how to do it. If you can't figure it out, you ought to ask me, or the math lab next door, by the way, which is open every day. Sometimes they'll tell you wrong, but it's okay. Sometimes I tell you wrong. You have to separate the wheat and the chaff sometimes. Okay, anybody want to talk about, I would like to go through the test, but I don't want to go through the test until you've all had an opportunity to digest it and to look at the problems and say, oh, I know that answer to that. Why didn't I do it that day? Whatever, to find out how can I help you guys, okay? Don't want to talk about it anymore now, but we can talk about it tomorrow or next day, whatever. Anybody have anything to tell me?
I have a question.
Sir.
So was the score that we got on the test, is that just our raw score that we?
Yeah, right now it is. And so if we didn't have another test, that would be entered in. Okay. Sometimes I've taught the class where everybody's got to get an 80. In other words, if you had 5 tests, you got to get 400. And getting 85 is no better than getting 82 or getting 90. This 80 is the A. And so what people try to do is get to 80. And if in 95, that extra 15 doesn't help them any. I'm talking about right now, the person with 94 right now is, if an A is 80, I'm just making that up. But if an A was 80, right now, this person's got 14 points kind of extra right now that they could get a little bit less on the next test and still would average. That's kind of the traditional way people take tests. So if somebody has a 54 and gets 100 on the next test, they just change to 77. Okay, that's kind of how we're doing it now. Except if I give you retakes, hopefully any score here is going to go up. I'm hoping to give everybody A's in this class, okay? If I gave out the grades right now, how many A's would I have? One. Well, maybe,
That's not an A,
maybe
because
2, maybe, you know, but I wouldn't have 15 A's right now, right? You would say.
94 an A because it's 94 out of 110, which is 85%.
Okay, she's saying maybe I don't have any A's.
No, there you go.
Okay. Anyway. Okay, so let's talk about the class math stuff we're supposed to be talking about. What did we learn yesterday? What I tried to tell you yesterday? We talked about chain rule, and we talked about quotient rule, and some of the harder things in this section about doing, and what I thought we might do today, and what you should be doing without me, is as many problems as you can get your hands on. And so I would suggest, everybody's supposed to have a textbook, I would suggest we go in the textbook and look for some problems. And by the way, you can bring problems to me if you want. I mean, if there's certain ones, like I could never do this one when I was in high school or something, whatever. You can bring things to me if you want, and probably I can't do it either. But I thought what I would do at the moment is look into the review section, because the review section has a number of problems. And my problem is today with my vision is I can't see the book, but that's okay, we'll make it through. So in the review section, there are problems on page 197 starting with problem 13 and going through problem 40 and so on. And then later there's some more. This is just the review section. Now, I know you haven't got to the review section yet, so therefore the problems we do are fresh and you probably haven't done them yet. That's why I'm going there. You guys ought to be looking at all the examples in the text. The book divides things up. They do the chain rule in one section, and for example, and so the chain rule problems you'll find in a certain place. But I was trying to compact it all so when you look at a problem, you think, okay, is this a product, a sum, a composite? What is it? And I wanted to have all those tools available to attack the problem to find the derivative once I decide what tool to use. Okay, so problem number 13. Problem number 13 in page 197 is y equals, but the trouble is those exponents hard for me to see with my dilated eyes. So I will make up something. It may be correct and it may not be. This is x squared plus something to a power. Oh,
X cubed,
x cubed, and the power is 4 or something.
and then x squared and x cubed are raised to the fourth power.
Raised x squared and x cubed. Thank you. I'm sorry about the dilation. I argued with the doctor, but they said, well, you won't be able to see, but you know, that's the way it is. Okay. So how would I differentiate this? First, notice it's giving us y equals. I personally prefer to name functions like this instead of y, but it is traditional, and you guys know that. For years, you've used y equals f of x. That's just something we say sometimes, and I know it's familiar to you. So whenever you see a y equals, they're just saying y is the second thing in the ordered pair. First thing is called x, and since it's a function, y is f of x. So I would rather do this. The book is going to say, okay, find this. And I hope that you all know that's the same as finding this. They're also doing it at every x because we're not just doing it at a single point now, because we know that these things are polynomials. They're differentiable everywhere. So I don't have to do it at one point. I can do a formula for all points at one time. But this was first one, problem 13, is a composite. It's a composition. I just learned I can't cover my face when I make a noise. Anyway, it's on the recorder forever that I made a little noise here. It's a composition, fourth power. The inside function you can see here. It's a combination, it's a sum. The outside function is the fourth power. So what do? You differentiate the outside first, and that would be 4 times the inside cubed. So far, all I'm doing so far is differentiating the fourth power function. It's 4 times the thing, whatever the thing is, to the third. That's the power rule. What do I put inside? Do not put the derivative inside. Put the original thing inside. Okay? I hope everybody listens to everything I say. I said to you, I have to run the tape back. 5 different times in the last several weeks, I told you when you negate an if-then sentence, you get an and sentence, not an if-then sentence. And if on your test you start your negation with the word if, you're going to get 0. 5 times. Unfortunately, I remember what I said. Okay? It's not fun. Anyway, you replace the inside as if it never hurt anybody, never changed anything. You don't differentiate it yet. Leave it alone. I don't care how bad it looks, just leave it alone. See, the worse it looks makes you upset because you don't like the way it looks. But after you get it done, it looks horrible. Then you like to show everybody, see what I can do? This is awful. You know? Then you're proud of this thing nobody else can read. Because then they think you're smart, you know? I know, been playing this game for years. Look, Mom. You know? Okay. Now, what have I left off here? I got to differentiate the inside. The inside's a sum. So that's 2x plus 3x squared. I think. And leave it alone. That's it, that's done. Don't multiply it out, don't spend another hour trying to change it. There are reasons later why we might want to do something to this. But right now, that's it, leave it alone. You know, if I had 2 and 4 here or something, I might take out something. Here I have an x and x squared. I could take out x. I can write it differently. But right now, I'm not trying to learn how to do algebra. That's called 10th grade. I'm trying to learn how to do differentiation. And so this would be good. Now, if you did this in the WebAssign, and there was a 2 and a 4 here, and they want you to put 2 out there and make 8, well, that's the author of whoever wrote the program in WebAssign. That's not my fault. Okay. So, and by the way, one of your lot asked me to extend the number of available times so you can work on something. And so for that particular person, I raised the number. If some of the rest of you would like to have the number raised, I don't know how large I can make the repeats, but I tried 5 last night and it worked. So I thought, well, so I tried 8 repeats and it worked. So right now, that particular individual can have 7 repeats because 8 worked. I don't know if I put 100 in there whether it work or not, but I'm hoping that that solved the problem for that person. But anyway, since it worked, I've never done that, but since it worked last night, anybody else who's after 3 times, you still want to do the problem, you know, I'd be happy to raise that for you, okay? Anyway, so this is the answer to the first problem. We've got to do more problems. Number 14, 1 over the square root of x and maybe. So, gotta go over here. This is the 14th one. And I think it's that problem, but I can't see it. For those of you who are coming into class late, probably, what's the world? Well, is that right?
No, it's not. The 3 should be a 5 and the 2
should be a 5 and the 2 should be a 3 or something?
Yeah.
Okay. Now, when you guys get to be 79 and a half, I hope you still have 20/20 vision like I do. But today, you know, driving here was fun.
Wait, what?
Okay, so I have f of x is this. How do I do it? Okay, well, I don't do it in this form. I don't want to do a quotient rule. Quotient rules you do because you know what else to do. I could do a quotient rule. I could do a reciprocal rule. But what I see here is to change this to x to the minus 1/2 so I can do a power rule. Because I think that's easiest. But we could do it other ways. But it is a sum. Don't do a product rule on the sum. Okay? The other one I would change to x to the minus 3/5. So this is how I would change it. So somebody said something. Yes?
That's not a plus, it's a minus.
This is a minus? Okay. Now, those changes are because I can't see, but the point is it doesn't change the derivative part really. It's changing the answer in the back. Okay? Or on WebAssign. Try to copy it right. So I haven't, now, sometimes I have seen that people get so excited about being able to do this right, they forget to differentiate it. You know, takes you 3 lines to get it to where you'd like it, and it's like, oh, that's great, and you just go on, do the next problem. So we have to differentiate the thing. Now I have power rule twice. I have minus 1/2 because we learned we can do that. Now, this is the problem of what do I put in the exponent. What you got to remember to do is to subtract 1. You subtract 1 from minus 1/2, that gives you minus 3/2. There's a danger that some people will get plus 1/2 because they add and subtract in the wrong way. Now, you will probably do this right for about a month until we get into integration. When we get into integration, it turns out we go the opposite direction. Okay, so here we're doing something in negatives and we decrease it. If I were integrating this thing, I would be increasing it. And as I say, you do it and everything's fine, and you get into the other part and you do the thing, and then you got to sometimes decrease it and sometimes increase it, and then that's when it gets complicated because people forget which way is which. Right now, it's decrease the thing if it's negative. This is a further away number from 0 than this is. Okay, and I have the other one, and it's minus 3/5. So I have a danger of the minus minus. So what you'll notice here, I put parentheses in because otherwise the minus I might see the minus. If I write it down, the phone rings. I might think, oh, I've already put the minus down, and then I'll make a mistake. It's minus 3/5 x to the minus. Now I gotta do this dumb arithmetic. So you go to your calculator and say it's minus 1 and 0.6. It's minus 1.6, and then don't do that. You know, in fifths, 5/5 is 1. 5 and 3 is 8. It's minus 8/5. Don't give me decimals to 27. I don't care about that. Okay? All right, so this answer, more or less. Now, probably what I would do in this problem, I might change this to plus. Then I might, well, maybe I should take the minus out of both of them. I mean, there's various things I could do here. Also, remember that the original problem was this way, not this way. So maybe somebody wants me to put it back into this form. But for right now, I'm learning how to do it. I'd leave it this way. Let somebody, they ask you to do it, you hand it back to them, they didn't know how to do it, so they don't know what the answer is. You say, this is the answer, they're okay. No. See, people, not wanting to record them. I was going to tell you something to get me fired. So I'll tell you after. Okay, so I've done 2 problems today. What's the next one? Oh boy. Now you're going to have to read this one to me too, because there's another exponent. But it's x to the some power 5. I never have trouble with my eyes. It's amazing. I can't see this. It's like a scientist in me says, study this. Okay. I'm having some. I didn't take anything internally, by the way. It was just my eyes. It wasn't anything that makes me some other way. My brain is the same. X to the what power?
Square.
Okay, let me see here. So the next one is x to some power. 2 and minus x plus 2. So we'll see what this is. Now, okay, so square root of x, I guess. Okay, now what we could do here is the quotient rule, because I have a quotient. Perfectly okay to do. You ought to practice the quotient rule. There's a section where you'll do a bunch of problems where it's natural to do the quotient rule. I wouldn't do that. I would do more quickly, say, hey, this is x common denominator, okay? 3 places. And make this into something that looks like that over there. In other words, this is x to the 1/2. So I got x squared over x to the 1/2. What do you learn about the same base? You subtract the exponents. So this becomes x to the 3/2 minus x is x to the 1 over x to the 1/2. That's minus x to the 1/2. And the 2 is x to the minus 1/2. So if it worked for me before, it will still work for me if I change it all to this. And once I do this, now it's going to be 3/2 x to the 1/2 minus 1/2 x to the minus 1/2 plus 2 times minus 1/2 x to the minus 3/2. You ought to be also able to do this out in space, talking it. I can talk my way through this and know what each answer is and say it. That's what you should be getting this, make this familiar to you. Somebody says, what's x cubed? Derivative is 3x squared. You shouldn't have to write it down. You need to do enough problems so these things become normal to you. Now, suppose that you didn't want to do that. Suppose you want to do the quotient rule. Then that's the denominator, which if I didn't change it is x squared root of x times the derivative of the numerator, which is 2x minus 1 minus That was the denominator times the derivative of the numerator minus the numerator, just copy, times the derivative of the denominator over the denominator squared. Now, this would be using the quotient rule. I gave you a problem on a test which involved x plus 2 over x plus 2 over x plus 2 over x. If you remember, very few people got that right. So what does that teach me? It didn't teach me anything. But what did it tell me? It told me you just aren't used to doing computations like this. So when you do a quotient rule, look what you get. One of the reasons for this on the test was to find out who needs practice in this kind of stuff. Because, look, here it comes up in problem, whatever it is, 14 or 15. I can avoid it by changing the thing to begin with. But if I don't avoid it, I have to simplify this. And what I got over here is a denominator and the numerator. You've got it. Now, if this is hard for you, you've got to go back and review more algebra. This, I don't like it, but I know how to do it. You see? And what this looks like, by the way, is A minus B over C over D. That's the look of it. And so what you should know is that's AC minus B over DC. It ought to be second nature to you by now from high school. If it's not, you'll have to go practice the stuff. Okay? When I see this, because I've been doing it so long, I just see how to do it. You need to do problems because you guys are all smarter than me. You should do things, lots of stuff, so you get good at it. It's not smart, it's practice. Now, so how about this problem on the test? What I would have done, if it had been my problem, is, and was this the correct problem?
Yeah, that's it.
Okay. I would make a common denominator right away in the first fraction. And I would make a common denominator in the second fraction. But once I have a common denominator in the second one, I know I can turn that over. The division here is turn that over. So what I would have in the second one right away is 2x over x squared plus 2. And now it's already simpler. Now I've just got two fractions and I need a common denominator. And what you guys ought to learn, if you haven't, is not to look for common denominator, all that kind of stuff. It's AD plus BC over BD. So this is x squared plus 2 squared plus 2x squared AC plus BD over x times x squared plus 2. I ask you to make this into a rational function. This is now a polynomial over polynomial. It's a rational function. I can square this out and make it simpler. Someplace there should have been a minus someplace. There's something wrong with this. It's not the same as the one I gave you.
Yeah.
There's a minus in one of these. You guys have your test.
We can ask them about.
This is the same kind of problem, but one of them had a minus in here. The test you took had one of the two things had a minus, and therefore it doesn't come out exactly like this, but the same idea. Make a common denominator right away, then you get a fraction, just add fractions. That's the way I look at it. So I think this is a simple problem, but a lot of people miss it. So what do? Know you missed it, swallow your pride, and go back and do stuff like this. Okay? You don't want this kind of stuff stopping you from doing calculus. This has nothing to do with calculus. It has to do with manipulating algebra. Okay? So I'm not trying to be mean. I'm trying to be hopeful. See, if the problem is not the calculus, maybe the problem is doing algebra. Okay, so go back and do some of those diagnostic tests if you didn't before. Anyway, I know it's taking us forever. We have tangent over 1 plus cosine. Next, tangent over 1 plus cosine. Now, let me ask you guys home and abroad here, is this a good thing to be doing today? Is doing problems like this helpful, or would you like, why are we wasting time?
No, this is helpful.
Is this okay?
Yes, this is good,
Okay.
yes.
Okay, tangent one, because I'm not doing lots of problems. You know, I can look at these problems and just say the answers, boom, 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 just because I know the rules so well. All right, so I could go through the whole set of problems in a few minutes. That's not bragging. That's just doing thousands of problems. I can see the answer. I've seen them before. Okay. Anyway, tangent of 1 plus cosine. So do as many problems as you can stomach. Now, sometimes when you see something like this, sometimes you say, okay, if I do this direct, it's a quotient rule. By the way, you can make all quotients into products by making the denominator -1 power. Some people like to do that. We'll be seeing here options sometimes. So I could make this, if I wanted, tangent x times 1 plus cosine x to the -1. That's a product rule now with a composition, and I could do it that way. Okay? But what else might I do? I might say, well, I don't like the looks of this thing. Maybe I can change this to sine over cosine over 1 plus cosine, and maybe that will make it simpler, because that makes it sine over cosine times 1 plus cosine. Now, by the time you did all that, I think you decide it doesn't make it simpler. But when you don't know, try it. Manipulate it. Tangent is sine over cosine. You're supposed to know that. It might make it simpler if you changed it. On the other hand, it might make it worse, or it might make it the same. So, but that's the experience. That's doing lots of problems. Okay? I wouldn't here multiply by a conjugate, because I'm not taking limits. But I could. You know, maybe I could change it that way too. So I could manipulate it before I differentiate it if I wanted to. But probably I just differentiated, which for this time means the quotient rule, which is the denominator times the derivative of the numerator. Now, you've got to know these functions. Derivative of tangent is the secant squared of x. We can go over those rules if you haven't done them for yourself yet. Okay? But the derivative of tangent is secant squared. Now, where am I? Denominator times the derivative of numerator minus, don't forget the minus, the numerator, tangent x, times the derivative of the denominator. Derivative of the denominator is a sum. Derivative of 1 is 0. The derivative of cosine x, oh shoot, I always forget the derivative of cosine x. Minus sine x. I say that minus sine x because some people forget the minus. But, so, this would be minus sine x, yes? So far, so good. Now, I'm so happy to get that far, I forgot the denominator. Did I forget the denominator over here? Here's the square root of x. There's an x. What am I supposed to do? I'm supposed to square the original denominator. I didn't forget it. Okay, might have forgotten. Didn't forget it. So I got to do, what was the original denominator? Oh boy. 1 plus cosine x squared. Now, as long as you're not in Webasine, leave it alone. You did the derivative part. Now, would I leave it alone? Probably I might minus plus here. I might look at sine over tangent to sine. I don't know if I go sine squared over cosine. I don't know. Here's 1 over cosine squared. Maybe I can make this look better. But now, oh, yes, important. A plus B over A. I want to simplify. Democracy. Not a majority, but 7 people on the test came up with something like this. Not exactly, but something like this. They said, oh boy, cancel. Anything wrong with that? A lot wrong with that. You're not allowed to do that. So look on your test when you try to simplify something and see if you canceled something that was a sum in the numerator and canceled a piece of it. That's a bad mistake. Okay? So anyway, meaning, hey, I see this thing here and I see two of them here, cancel one. No. Why not? Because this is not multiply, this is subtract. Okay? But I would leave that alone. I did it. I did the derivative part, so I've done 4 problems today. Okay, number 12. X squared sine pi x. X squared sine pi x. So anybody know what you do this time? X squared sine pi x. I see that as a product. A little composition in here, but I see this as a product. The derivative is 2x sine pi x plus x squared pi cosine pi x. Now, I just see that. Now, what do you see when you see to differentiate this thing up here? Product, where you differentiate this one, you get 2x. You leave this one alone. That's why I got that. Plus, leave the x squared alone and differentiate the sine, which is the cosine. This is now a composite. You differentiate the cosine and leave the inside alone. Then you differentiate the inside, and that's where the pi comes from outside there. And you want to do enough problem. When I see that, I just can read it off to you. The derivative I'm talking about. And it's not because I'm special. You can do it too, but you've got to do problems. You're going to hear me say this a lot. And after the next test, when we get some more 50s, I'm going to tell you should have done more problems. On that way. Okay, so, that next one. I can't put my glasses on. Oh, want to see something fun? Not fun, but eye doctor said you got to wear this. Now, you tell me how I can get this on my glasses, because I tried for 10 minutes. Anyway, used to be they gave you sunglasses. Now they're cheaper. Now they give you a thing and say, you put it on. Okay? And by the way, I got it somewhere. Yes, I got 2 of them because the doctor couldn't do it either. But he kept it. I got the outside. He kept the inside. Anyway, I just felt it in my pocket. Okay, I got x plus 1 over x squared to the, what the heck is that? Square root of, oh boy. Okay, now, sometime in the book, you'll come up with stuff that we haven't talked about, maybe. What about, was that x squared plus 1 over x or something like that? I can't read.
Which problem?
Problem 18 says, I can't even read that. 18, x plus 1 over x squared to the sum power.
To the square root of 7 power.
Square root of 7?
Yes.
Interesting. I could pay $100 and I wouldn't believe that. Square root of 7. Looked like a z to me. Now, what's z being in this thing?
And the x in the denominator is also yeah.
Okay, thank you, sir. Okay, so what do we do? Differentiate. Well, the square root of 7 is a number. Power rule. This is a composite. It's 20 after. This is a composite. So, I don't know what square root of 7 power is. Don't worry about it. It's just a cactus thing. No. You take the derivative and you decrease it by 1. Now, don't give me this to 10 decimal places. It's the square root of 7 minus 1. That's a perfectly legitimate number. I don't care that square root of 7 is 2.44986. I might know, but I don't want to know that. I don't have to have a calculator because you wouldn't want anybody to memorize all those things, right? I have to have a calculator if I tell you it's 2.4. So I happen to know these numbers anyway. Why? Because I'm old. We had to learn them. Square root of 7, can't deal with that. Got to know what it is to 6 places. Okay. You guys don't know that, but I do because I'm old. But I never used it. You know? Anyway, this is a perfectly legit, leave it alone, okay? It's this times this minus 1, leave the inside alone because it's a composite. It's just a chain rule. Then I have to differentiate the inside, which is 1 minus, this is x to the minus 2, that's minus 2 over x cubed. I'm running out of time. So what happened? All of a sudden, problem 18 got harder because it's in a format that you're not familiar with so much. But all it is an outside, inside. It's a chain rule. And the square root of 7 you got to learn is not bad. It's just like 3. It's just when you differentiate third power, you get 3 times the second power. When you differentiate square root of 7 power, you get square root of 7 times square root of 7 minus 1, whatever it is. And it's okay. Don't, like, what do I do? Leave it alone. See, you leave it blank because you don't know what to do, and you get it crowned right on the test. This is great. I'm going to stop the recording and tell you one more thing here. Just read down. I didn't stop the recording on